Section 1 of The Science History of the Universe, Volume 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Avai in July 2015. The Science History of the Universe, Volume 1, edited by Francis Rolt-Wheeler. Astronomy. Chapter 1. The Evolution of Astronomical Ideas. Herbert Spencer has stated that evolution is a change from the indefinite to the definite, from the incoherent to the coherent. If any proof of that doctrine were required, it would assuredly be found in the development of astronomical conceptions. In this chapter an attempt will be made to outline in a general way the manner in which the present theories were evolved from the mysticism of folklore and religion. Some of the matter herein presented is drawn from Arrhenius' Die Vorstellung vom Weltgebäude im Wandel der Zeiten. The astronomical beliefs of prehistoric men were no doubt similar to those entertained by the Eskimo of the Arctic regions and the untutored tribes of Argentine Republic, South Africa and Australia, tribes who, living only for the day, concern themselves but little with tomorrow and yesterday and care nothing about the universe. Somewhat more cultured than these Eskimo and South American and South African tribes are primitive nations who have endeavored to account for the origin of the earth and the heavens by anthropomorphic theories. The universe must have been created by some personal being who had at his disposal something to mold. The idea that the universe was made out of nothing is a philosophical assumption which was introduced by the highly cultured philosophers of the East. The something out of which the universe was created is usually regarded as water, an element which to the eye at least is perfectly homogeneous, shapeless, and chaotic. That the fertilizing mud was deposited by floods must have attracted the attention of ancient primitive races, for which reason they may have assumed that all the earth was slowly and gradually deposited from water. Thus we find that Thales (550 B.C.) argued that all things were created from water. Yet other substances were assumed as primordial matter, and later Anaximenes of Miletus, who also flourished in the 6th century, called the generative principle of things air or breath, while Heraclitus, who flourished at Ephesus near the end of the 6th century, believed that all bodies were transformation of one and the same element, which he called fire. The belief that primordial water is the origin of all things was deeply rooted in Asiatic races, for it occurs over and over again in many creation myths, among others in the Chaldean and in the Hebrew. Instead of water, we sometimes find that an egg may be taken as the primal unit, no doubt because every organism springs from an apparently lifeless seed. Thus we find that the egg plays a most important part in the creation myths of the Japanese, as well as in narratives from India, China, Polynesia, Finland, Egypt, and Phoenicia. In many of these creation myths, of which I. Riem has collected no fewer than 68, more or less independent of one another, deluges are prominent features. In nearly all of them it is supposed that after the water subsided, the land was exposed, fertilized, and made to bring forth. All of these creation myths are interwoven and interconnected with religious belief. To the savage mind, everything that moves is endowed with a spirit. Accordingly, primitive man endeavors to propitiate the spirit by magic, knowledge of which art is given only to the medicine man or to the priest. In a certain sense, therefore, magic is the precursor of natural science, and the myths and lore upon which the practice of magic is based are remotely antecedent to our scientific theories. According to Andrew Lang, myths are based as much upon primitive science, resting upon superstition, as upon primitive religious conceptions. In Maspero's Histoire ancienne des peuples de l'Orient classique, we find an account of the Chaldean conception of the universe. Surrounded on all sides by the ocean, the earth rises in the middle like a high mountain whose summit is covered with snow from which the Euphrates springs. The earth is encircled by a high wall, and the abyss between the earth and the wall is filled by the ocean. Beyond it is the abode of the immortals. The wall supports the vault of the firmament, shaped by Marduk, the sun god, out of a hard metal, which shines in the daytime, but which at night is like a blue bell set with stars. In the morning the sun enters the vault by an eastern entrance, and at night makes its exit by a western outlet. Marduk arranged the year according to the course of the sun, and divided it into 12 months, each of which counted 3 periods of 10 days. The year, therefore, numbered 360 days. Every 6th year a special year was intercalated, so that the year had on an average 365 days. As the lives of the Chaldeans were to a high degree influenced by a change in the seasons, they laid great stress upon division of time. In the beginning they probably based their chronology upon the movements of the moon, like many another race. Soon they recognized that the sun exerted a stronger influence, and accordingly they introduced the solar year, whose divisions they ascribed to Marduk. The stars were observed because their positions determined the seasons. Since the seasons govern organic life, a pernicious belief in the influence of the stars took root, a belief which prevailed for 20 centuries, and which crippled the advance of science up to the time of Galileo. Diodorus Siculus, a contemporary of Julius Caesar, describes this astrology in the following words, as given in a translation by Philemon Holland, 1700. Quote, "Therefore, from a long observation of the stars, and an exact knowledge of the motions and influences of every one of them, wherein they excel all others, they (the Chaldean astrologers) foretell many things that are to come to pass. They say that the 5 stars, which some call planets, but they interpreters, are most worthy of consideration, both for their motions and their remarkable influences, especially that which the Grecians call Saturn. The brightest of them all, and which often portends many and great events, they call Sol, the other 4 they name Mars, Venus, Mercury, and Jupiter, with our own country astrologers. They give the name of interpreters to these stars, because these only by a peculiar motion do portend things to come, and instead of Jupiters do declare to men beforehand the good will of the gods, whereas the other stars, not being of the number of the planets, have a constant ordinary motion. Future events, they say, are pointed at sometimes by their rising, and sometimes by their setting, and at other times by their color, as may be experienced by those that will diligently observe it; sometimes foreshowing hurricanes, at other times tempestuous rains, and then again exceeding droughts. By these, they say, are often portended the appearance of comets, eclipses of the sun and moon, earthquakes, and all other the various changes and remarkable effects in the air, boding good and bad, not only to nations in general, but to kings and private persons in particular. Under the course of these planets, they say, are 30 stars, which they call counselling gods, half of whom observe what is done under the earth, and the other half take notice of the actions of man upon the earth, and what is transacted in the heavens. Once every 10 days' space, they say, one of the highest order of these stars descends to them that are of the lowest, like a messenger sent from them above. and then again another ascends from those below to them above, and that this is their constant natural motion to continue forever. The chief of these gods, they say, are 12 in number, to each of which they attribute a month, and one sign of the 12th in the zodiac. Through these 12 signs the Sun, Moon, and the other 5 planets run their course." The Chaldean priests developed a most perfect astrology. They mapped out the positions of the stars for every day with such care that they could tell their true positions for some time in advance. The different stars either represented deities or were directly identified with them. If, therefore, a Chaldean king wished to know which gods ruled over his destiny, he consulted the priests as to the position of the stars on his birthday, and was informed of the chief events of his career. This Chaldean belief that the celestial bodies were gods transformed astronomy into a religion. Hence astronomical theories were promulgated only by the ruling priest caste. To doubt the tenets of that caste was to expose oneself to merciless persecution, an Oriental trait that passed over to the nations of classic antiquity and to the semi-barbarous nations of the Middle Ages. The Jews appropriated the Chaldean conception of the universe, but modified it, so that it was transformed from a polytheistic to a monotheistic conception. No doubt the Chaldaic accounts of the beginning of the world influenced Egyptian thought. According to Maspero, the Egyptians believed that matter without form was shaped by a deity, always a different person in different parts of the land, and by different methods, into the world as we see it. The classic nations borrowed much of Egyptian civilization, and with it Egyptian religion and science. For the Greek creation myth, like all the others, assumes that chaos once existed, and that out of it Ga, the mother of all things, and her son, Uranos, the god of heaven, were created. The Greek cosmogony was adopted by the Romans without noteworthy development. Hence it is that Ovid wrote on the origin of the universe much as Hesiod had done 700 years before. In that long interval of 7 centuries the study of nature had advanced but little. Indeed, it was not until the invention of the telescope that astronomy was lifted entirely out of the hands of the priesthood and placed upon a sure scientific footing. Before the invention of the telescope, therefore, astronomy appears merely in the garb of a myth. At its best it was metaphysical. The rudiments of astronomical science are to be found in the efforts of the Chaldeans, Egyptians, and Greeks to devise calendars and to mark time. That effort necessitated a study of the motions of the celestial bodies. Moreover, exigencies of husbandry rendered necessary some method of keeping track of the seasons so that seed time and harvest could be ascertained. The regular occurrence of such events as the Nile flood made requisite suitable preparations. Hence the early Egyptians so built their temples that they might know the time of the summer solstice, and hence the time when the flood might be expected. This was a matter of practical importance, not merely connected with religion or priestcraft, but on which the lives and the happiness of the people of Egypt depended, and might be compared with the modern time observations made at the great national observatories. The observation of the stars was carried on with at least this object in view, and gradually with the development of civilization, time reckoning from the stars became an important consideration closely connected with the lives of the people. With the study of the stars for such a purpose, naturally an amount of information as to their positions and motions was accumulated, and for centuries the practical side of astronomy was the study of the position of the stars and the motion of the planets. The astrology of the Chaldeans spreading westward increased rather than diminished the interest in the stars, for not only was the connection of the planets with natural phenomena and the mere reckoning of time studied, but the mystical element involving prophecy of future events attracted attention. In other words, astrology was a pseudo-science, for which reason it is difficult to estimate its benefits or to exaggerate its evil. In its scientific aspect it involved the observation and record of the position of the heavenly bodies with all the exactness that the mathematical and observational methods of the time could achieve. It enabled the motions of the planets to be studied, as well as the positions of the fixed stars and the course of the Sun as it passed through them. But, on the other hand, when the interpretation of the appearance of the skies was involved, superstition and poetic fancy had full sway, in which no doubt certain elements of self-interest and deception on the part of the priests or astrologers were not lacking. Hence these men did not study the sky to interpret phenomena on a scientific basis. Confined in the narrow limits of superstition, they not only made no progress, but actually held back astronomy as they did other sciences. That the work of the astrologer was mysterious there can be no doubt, and as no reason was assigned for the movement of the planets or the position of the stars, it was a natural assumption on the part of the people that some supernatural agency was at work, which also was connected with their lives and their future. With the beginning of the development of scientific astronomical theory proper, the power and position of the astrologers began to wane. Slowly, it is true, for when Tycho Brahe was invited to deliver lectures on astronomy at the University of Copenhagen, the first dealt very largely with astrology. Cardan and Kepler among the distinguished astronomers of the Middle Ages, Roger Bacon, Burton, and Sir Thomas Browne were among the men of mind who were interested, at least in part, in the teachings of the underlying basis of the cult. As explanations of the motions of the heavenly bodies on a rational basis were forthcoming, the doom of the astrologer, so far as participation in the scientific creed of the day was concerned, was sealed. If there was a natural explanation that could be accepted, how could supernatural influences condition the movements of the planets or the positions of the stars? If then these movements were natural and made in obedience to natural laws, how could they affect the future course of life and future occurrences that obviously had no connection with natural phenomena? The law of gravitation, which explained the solar system and the movement of the planets, corroborated this view, and left only the comets as striking natural phenomena which could not be explained in a way that the popular mind could grasp. With the rise of learning and the growth of observation, the explanations of natural phenomena by astronomers secured acceptance by the people. Finally, when Halley's prediction of the return of his comet, first made in 1705, was verified in 1758, the reign of natural law in the world of the heavens became an accepted fact from which only the ignorant or superstitious could dissent. Distinctly different and apart from astrological influence was the work of Copernicus, whose researches mark the beginning of the new and philosophical science of astronomy, in which the element of mysticism was gradually displaced and observation and reasoning were depended on. Copernicus, as will be seen when the development of theories of the solar system is considered in an early chapter, returned to many of the fundamental ideas of Pythagoras and the early Greek philosophers, especially that the sun was the center of the universe. He was a thoughtful student not only of Greek philosophy, but of the work of such later astronomers as Ptolemy and his successors, so that when he announced a theory of the solar system in which the Earth and other planets revolved around the sun as a center, it was based upon the fullest knowledge of previous reasoning and theory. Nevertheless, he was casting to one side the tradition and the science of the day as it was then understood, and presenting what was a conception of the heavenly world no less daring than original. His theory was a natural outcome of the revival of learning in the Renaissance, foreshadowed by the work of such men as Leonardo da Vinci and others in whom the scientific spark had been awakened. With Copernicus, the evolution of his heliocentric theory was a matter of scientific reasoning rather than of direct observation. But it marked the beginning of a series of epoch-making discoveries presented in a clear and positive form, so that the theory of the revolution of the planets around the Sun became one of the fundamental canons of astronomy. Thus, as will appear in the course of our history, the Copernican theory in which the revolution of the planets around the Sun is made clear, Kepler's theory of planetary motion in which laws are stated to account for this motion, and finally Newton's announcement of the great universal law of gravitation are the foundation stones on which modern astronomical science firmly rests. The invention of the telescope established the similarity in the bodies of the solar system and revealed facts that previously had been hidden from observers of the heavens. Indeed, with the invention of the telescope and the growth of mathematical science, there began an era of descriptional astronomy in which exact observation was combined with careful computation and mathematical analysis, an era which continued into the 19th century with undiminished vigor. Brilliant discoveries were made possible by improved and powerful instruments, accompanied by theoretical work of even greater value. In the middle of the 19th century, new instruments were put at the command of the scientist, which had a remarkable effect in extending the boundaries of the science. The telescope had facilitated merely the observation of the stars. The spectroscope, on the other hand, enabled the astronomer to ascertain their composition. With the application of the spectroscope to astronomy began the welding of physics and chemistry with astronomy, and the birth of that modern science of astrophysics, which has afforded data for the study of the serious problems connected with the evolution of the universe. From the soothsaying stargazer of Chaldean times to the modern astrophysicist, who works in a laboratory as well as in an observatory, we have a development that is responsible for the aggregation of knowledge, which we now possess of the vast universe with its suns, planets, stars, and nebulae. The spectra of distant celestial bodies recorded on the photographic plate by the spectrographs of large telescopes are now studied in comparison with the spectra of terrestrial substances produced in the physical laboratory. Not only the nature and composition of the stars can be ascertained, but also their motion in space, which are beyond the range of any telescope. The new astronomy has become on its astrophysical side almost an experimental science, with the methods and accuracy of the chemical or physical laboratory. It is from this modern astronomy, with its breadth and resourcefulness, that modern science looks not only for advances in its own particular field, but in the broader and ever interesting problems of cosmogony as concerned in the evolution of the stars and other bodies making up the universe. End of section 1.